Okay, first hour coming at you one more time this week. Got 5 examples, got to add and subtract this time. So the deal with adding and subtracting square roots, this number, that number, they got to be the same. This is a 3, this is 75, that ain't going to happen. So we got to go to work on this 75. So run him over here. Let's run a little factor tree on old 75. That's 3/4, so 3, 25, 5, 5. So we work our factor tree magic, and 75 we can break down to 355. So we run back into the problem. And 75 now becomes 355. And we remember the rule. We're still trying to grab any pairs, get them out of there. But on the outside, you only write it one time. So 2 on the inside, 1 on the outside. Clean this up, 6 times 5, that's 30. Square root's of 3, minus 20 square root's of 3. Now you can add and subtract your like terms. Square root of 3, square root of 3. So if you've got 30 of them minus 20 of them, 10 of these left over. All right, so that's working it with square roots. We can do the same math problem with cube roots. Let's do one of those right now. Let's do a cube root. All right, number 2. It's got 4, cube root of 7, minus 5, cube root of 56. So the first thing you run into is you're like, okay, I can't do anything with the 7, but that's definitely got some work to do. A 56, like, I've got to go to work on it. So grab 56. Let's factor tree that down. You're like, oh, 56, that's 8 times 7. That's 2 times 4 and 2 and 2. So once you break it down, you got a whole bunch of 2's and a 7. So let's get the 56 replaced with 2, 2, 2, 7. Now what we see is that we're out of the square roots. We're into the cube roots. So instead of looking for 2 of a kind, instead of looking for pairs, these are cube roots. So we're looking for 3 of a kind, a set of 3, which we have right there. So we're going to grab it, we're going to get it on the outside. And remember, the rule is still the same. 3 on the inside, you still only write it one time when it comes out. Clean up that 5 and the 2. So you've got 4 cube roots of 7 minus 10 cube roots of 7. And now you have some like terms that you can deal with. 4, take away 10, you have negative 6, cube root of 7 left over. All right, so adding, subtracting radicals, cube roots, square roots, fifth roots. Make sure you get them same number underneath the same root sign. We're in business. Okay, next type of problem. We got to solve for a few of these guys. We got to move. That's going to help us. Let's do some moves. Let's start easier and kind of work to harder. Let's solve some of these. Like square root of x plus 17 equals 22. So, into solving, square roots, here's the trick. You want the square root all by itself. So grab that 17, ship him out. So grab him over 22 minus 17, that's just going to be 5. So when you get to here, your x has this square root around it. Like, I don't want a square root around it. How do I get rid of it? Here's the trick. If it's a square root to get rid of, you can square both sides. It's a cool move. So square both sides. You're going to like this. The square root and the square and the square cancel out. That just leaves you an x on the left side. That's what the move is designed to make happen. And then over here, you got to take 5 squared, 25. And that's your answer. Not too bad. I wonder if we can get number 4 up here. Probably. We'll find out in just a second. I'm not even going to try. this out of the way. All right, let's do a number 4 and then number 5 before we call it a video good on today. 3, x plus 7. Okay, again, you want the square root by itself. Let's take care of the 2 right off the bat. He's negative, move him over, make him positive, add him to the 10. Okay, so 10 plus 2 gives me 12 on the other side. I still want this square root all by itself, and the 3's hanging out in front. So if your square root's been multiplied by 3, the opposite would be to divide by 3. So divide by 3, knock that out. Here's x plus 7 equal to 4. All right, square root is finally all by itself. Once it is finally all by itself, we can then do our new move of squaring both sides. Oh yeah. Let's square both sides. Here's x plus 7. Here is 4. Oh, it's good. The square root squared, square root squared. Cancel out. That just leaves me x plus 7. Then over here, 4 squared is 16. So we took it to a problem that had a square root to a problem with no square root. And I think we got that. Something plus 7 equals 16. I'm going to go with 9. Boom. Shakalaka. All right, we have done 1, 2, 3, 4 of the targeted 5 examples. We have 1 left. 1 example left. All right, let's try this last one. 5. 7 square roots of x minus 20, that's a lot of negative signs, equals negative 6. Okay, so again, you're solving this, which means you need the root sign by itself. Got to get rid of the 20, got to get rid of the 7. Let's start with that 20. We're going to add it to the other side. So he was negative 20. We move him over, becomes positive 20. Let's clean that up. Got a little math problem here. Oh, I think I see where we're going. You see the 7, you see the 14, you're like, I'm going to divide that, Mr. Porter, I got this. Yes, 7's been multiplied, so we need to divide it on both sides. Get it out of our way. Finally, we get down to here, a square root of x and a 2. We still don't like the square root sign being in the middle of our problem, so let's get rid of it. To get rid of a square root sign, the opposite of that is squaring both sides. So we throw it in, they cancel out. That's just x. You're like, yes, no more square root sign. I've got 2 to the 2nd power, that makes 4. And I am feeling good in the neighborhood. All right, guys, this was homework 36, 5 examples. There you go.